About freezing, what do we have going on out here?
Well, I got two really good questions from your viewers.
Yeah.
And the first one was a real challenge. It was explain the God particle in 15 words or less.
That came to us via Facebook from Bobby asking Mr. Matt Sullen here.
I like it.
From the University of Illinois to do that.
Right, and it's very topical because the Nobel Prize for Physics was just announced last week, and one of the recipients is Peter Higgs, and he's the one who predicted the Higgs field or the Higgs boson, which is also called the God particle, a long time ago, so many decades before it was ever observed. So anyways, 15 words or less is not very many, so I wrote a haiku.
Oh, beautiful.
Okay, so you're going to get the God particle in 12 words and 17 syllables.
Excellent.
Very nice. Okay.
So you ready?
Go for it.
Okay. Space is not empty. The Higgs field is everywhere, making us matter.
Ooh, I really
What do
like
you think?
that. That was good.
Okay. Now,
Double entendre there at the end, kind of?
yes, absolutely.
Lovely.
And so, you should have been playing the bongos during that whole thing. Yeah, exactly. So the other question that I got, which was a really good one from Rhonda, was about how a thermos works and how can it, one day you want to keep something cold in the thermos and keep it cold, and the other day you want to keep something hot.
Right.
And so what's that all about? And so that's a very interesting question. I like it very much, and it has to do, the answer has to do with the second law of thermodynamics. And it's basically the tendency of nature to want the temperature everywhere to be the same. So if you just leave something out on the counter and you wait a while, it's going to be the same temperature as everything else. That's why your food cools off if you put it on the table when it's hot, or if you have something really cold, it melts and warms up. So nature wants the hot stuff to become the same as the cold stuff, to be sort of just in between.
Okay.
And the way that happens is that heat flows from the hot stuff to the cold stuff. And so if we want to keep temperatures separate, we want to keep something hot over here or something cold over there, we want to prevent heat from flowing.
Sure.
Okay, and so that's what insulators do. And so, for example, here I have in this styrofoam cup, I have some liquid nitrogen. It's 300 below zero in there, and it's, room temperature here. And in just 1/8 of an inch of styrofoam, I can actually kind of hold this thing, and it doesn't feel that cold. So styrofoam is a good material to keep heat from flowing. What I have in this container right here, if we could kind of zoom in from top, in the bottom of this is liquid nitrogen, so it is very cold, 300 below.
Sure.
Out here, of course, is room temperature, and these different rods are made of different materials, and you can see that some of them are frosted up more and some of them are frosted up less.
Right.
Okay? And so the ones that are frosted up more, those are the ones in which heat can flow more easily, because all the heat that was in this copper rod, for example, has flown into the liquid nitrogen, attempting to warm it up. Okay? And so the rod became very cold, and the moist air from this room condensed onto the rod. Okay, so you can see the very frosty ones are therefore materials that are good conductors of heat, and the ones that aren't frosty are materials that are bad conductors of heat. Okay, and if you don't believe me, you can touch these. So if you stick your finger, Drew, on the end of this copper one,
Gladly.
you'll feel that it's very cold.
Indeed.
Okay? If you stick your finger on the end of this wood one, well, hardly anything happens at all. Okay, so the wood is a poor conductor of heat. Copper is a very good conductor of heat. These other things are kind of in between. This one's aluminum. Okay, so you can see it's not quite as frosty. It's not as good a conductor. This one is brass. It's even less frosty. Okay, it's a worse conductor. This one's interesting. It is stainless steel. It's not a very good conductor at all. And if I ask you, what do these heat conductors have in common? What would you say? Well, you're not prepared for that question, so I'm going to answer it for you. And it's okay. They're all very good conductors of electricity.
Oh, yeah.
Okay, so electrical conductors tend to also be very good heat conductors.
Okay.
So copper is a very good electrical conductors. Aluminum is not bad. Stainless is a bad one. And of course, wood, you don't build house wiring out of wood. That would be silly. Okay.
Yes,
and so that's sort of the answer. So things that have a lot of extra electrons that conduct electricity well also conduct heat well. And so if you want to keep heat from moving, you don't want to have a metal cup. Okay? So the last thing I want to just point out is that the container that this liquid nitrogen is in is made of stainless steel. And so you'd think that's not a really great insulator, but a really very good insulator is nothing at all. Right? So this thing has a vacuum pockets. It's only connected, the inside and the outside are only connected at the very, very top. Then there's a space in between the inner container and the outer container, which is filled with nothing. It's just a vacuum. Okay, and nothing is very good at insulating because there's no way for heat to get from one side to the other by going through nothing, or at least it's harder for heat to do that. It can do it, but it's not as easy as just flowing through material.
Very interesting.
Okay.
Good stuff, man.
Okay.
Appreciate it. If you have any